Nikola Tesla, the Sorcerer's apprentice. One of Tesla's most ardent admirers was Yale student Lee de Forest, who had studied the inventor's collected works the previous semester. Tesla's writings are the greatest exciters to zealous work and study, de Forest wrote in his diary. His New York laboratory is a fabulous domain into which all ambitious young electrical students aspire to enter, and there remain. How I pray that I may equal or excel him, that all this belief in my genius is not idle and conceit. In May 1896, de Forest was able to arrange a visit to the East Houston street den. Now is the critical point in the curve of my life, the youth scribbled on his pad as he sat on the train waiting for his stop. For I am about to seek work with Nikola Tesla. The expert greeted the novice and gave him ardor, but was unable to take him on as an apprentice. Noticing the dejected countenance on the budding inventor's face, Tesla told de Forest, "I see a great future for you as you are endowed with arcane mind. You will not need this job to succeed." Tesla wished him well and suggested de Forest contact him again. De Forest would apply once more in the spring of 1898, and probably again in 1900 or 1901, but for various reasons he was never hired. In retrospect, Tesla's decision to reject the talented engineer was unfortunate, for de Forest would soon rise to a premier position as a pioneer in the field of wireless communication. He had a commercial mind and became a tenacious rival to Tesla's other young competitor, Guglielmo Marconi. Throughout 1896, Tesla applied for and received 8 patents on his wireless system. These were mostly different types of oscillators for generating electromagnetic currents of high frequency and high potential. His first application specifically in the field of radio communication was in 1897. His second, remote control, in 1898. Earlier patents on oscillators dating back to 1891 and 1893 also covered this work, though in veiled form. Over the next 5 years, the inventor's arsenal grew to 33 fundamental patents, covering all essential areas of transmitting electrical energy through the natural medium. As part of his overall scheme, Tesla also began working on perfecting a system of telephotography. His interest could be traced to 1893 and the Chicago World's Fair, where Elisha Gray's telephotographic machine was displayed. But over the summer of 1896, competition peaked, especially when Edison announced his plans to market an autographic telegraph. "I'm getting it ready for you newspaper fellows," Edison said, "and when I get working, all you will have to do is hand your copy to the operator, say in New York, for example. The cover will be shut down and presto, the wires will transmit it letter for letter to the machine at the other end in Buffalo. The wires will transmit 20 square inches of copy a minute and will carry sketches and pictures as well." In attempts to tutor this, Tesla taught the New York world of fission advances, under the imaginative assumptions that images from the retina could be captured and transmitted. Tesla included this esoteric idea along with a more realistic plan to transmit text and pictures over the phone lines and by wireless. Even today, the facsimile machine holds a special place in our imagination. For something typed in an office in New York can be transmitted instantaneously by satellite or over the phone lines to a server in San Francisco, Moscow, or Tokyo. One can only imagine the sense of disbelief facing Tesla as he tried to convince readers that pictures could be sent by means of wireless from one city to another. Even primitive Morse-coded messages had yet to really be effectively transmitted. Nevertheless, Marconi was closing in rapidly on successfully demonstrating his wireless apparatus as Tesla scoured the libraries to study the history of telephotography. Tesla traced early work in inventions that led to the development of the facsimile machine and television to English physicist Alexander Bain, who, in 1842, first transmitted pictures by using a grid of electrical wires embedded in wax held firmly beneath a sheet of chemically treated paper. All of these wires could be channeled into one cable and strung to a receiving station where an identical grid was constructed. If the receiver traced out the letter A, for instance, with an electric stylus, the particular wires comprising the design of the letter would be electrified, and these, in turn, would treat that area of the paper on the receiving end to spell out the matching character. Autographs and drawings could also be transmitted in the same manner. As the process evolved, pictures could be broken down into a finite number of picture elements so that they could also be dispatched. In the 1860s, this grid was replaced by a single wire through the implementation of spinning discs and perfect synchronism between transmitter and receiver. Tesla's synchronous AC motor helping augment the procedure in the late 1880s and early 1890s with the development of the photographic process. The first wireless pictures were sent in 1898 by K. Sainter and G. Williams, but the arrangements involved the employment of Hertz waves and were impractical. In 1892, Tesla recalled many years later, the attention of the scientific world was directed to a wonderfully sensitive receiver, consisting of an electron stream maintained in a delicately balanced condition in a vacuum bulb, by means of which it was proposed to use photography in the transmission of telegraphic and telephonic messages through the Atlantic cables, and later also by wireless. In 1904, Dr. Arthur Korn, an electrical engineer from the University of Munich, gained the attention of the scientific community when he successfully transmitted wire photos from Munich to Nuremberg. According to Korn, who is often credited as the inventor of the television tube, the apparatus utilized Tesla currents. Tesla notes that once Korn introduced a sensitive place and a selenium cell to vary the intensity of the sending current, the process which is called the television advanced agent step. Korn's tube is excited by a high-frequency current supplied from a Tesla transformer and may be flashed up many thousand times per second, thereby attaining the moving television image. Tesla dates Korn's first experiments to 1903. A May 1899 article states that Tesla was working on a visual telegraphy system with the light-sensitive element selenium, thus predicting Korn's work by 4 years. It is probable that Tesla was replicating the experiments of K. Sainter and Williams on precursors to the video camera, although Korn, not Tesla, perfected it. In essence, the modern television works in a way analogous to Bain's first 1842 construction. An electronic tube, similar to Tesla's brush vacuum tube, is moved across an entire TV screen in an instant. During its pass over the area where the image is formed, it releases synchronized impulses for each pixel. The position of the beam and its precise sequence of firing are directed by impulses stemming from the broadcast station. Each pass over the entire screen creates a separate image that, when played in sequence, portrays natural moving pictures. Tesla followed the advances in the field of telephotography as they occurred and experimented himself. His first task was to figure out the optimal way to transmit the energy. Having tested the Hertz spark gap apparatus, Tesla found that this device, which Marconi was utilizing, was subject to static interference and involved arbitrary pulsed damped frequencies that were weak. They transmitted themselves transversely through the air and did not take into account longitudinal properties, which were augmented when making use of extremely high potentials and a ground connection. Working out calculations that took into account the speed of light and the size of the Earth, Tesla designed carefully constructed continuous undamped electromagnetic waves that were in harmony with those of the planet. By 1897, Tesla amassed all of the essential patents for generating, modulating, storing, transmitting, and receiving wireless impulses. In a letter to his lawyer, Parker W. Page, Tesla wrote, "I forward herewith Militer's Marconi's patent, which was just allowed." He noticed that the signals have been described as being due to Hertzian waves, which is not the case. In other words, the patent describes something entirely different than what actually takes place. How far does this affect the validity of the patent? Clearly, Tesla already suspected that Marconi was utilizing his equipment. In Tesla's first patent specifically for wireless transmission, number 649,621, filed on September 2, 1897, he discusses the need for a terminal, preferably of large surface, maintained by such means as a balloon at an elevation suitable for the purposes of transmission, and another terminal of the secondary, connected to the Earth. At the receiving station, a transformer of similar construction is employed. The specification goes on to describe how the wavelengths can be constructed and modified so as to tune the circuits and take into account the natural properties of electromagnetic energy. Having taken into account the size and capacity of the Earth, Tesla had calculated that with a coil 50 miles in length oscillating at 925 times per second, a resonant relationship to the frequency of light was realized. Since he had worked with exhausted tubes, Tesla knew that electricity traveled more easily through them than through air. Thus, he reasoned, if his transmission towers were placed on high elevations above abstractions and further raised by the use of balloons, the upper atmosphere or ionosphere itself would serve as a means of transmission. Large power stations located near waterfalls would supply the energy necessary for the wireless transmission to this upper stratum. In a separate way, the Earth itself would also serve as a medium. The following passage from the same 1897 patent application criticized Marconi's use of the more primitive Hertzian apparatus. It is to be noted that the phenomenon here involved in the transmission of electrical energy is one of true conduction, and is not to be confounded with the phenomena of electrical radiation which have heretofore been observed, and which from the very nature and mode of propagation would render practically impossible the transmission of any appreciable amount of energy to such distance as are of practical importance. Marconi, who was working with Lloyds of London in ship-to-shore experiments, was using a more trial-and-error method. In July 1896, in experiments with Prius, the Italian had successfully transmitted messages through walls and over distances of 7 or 8 miles. In December, he applied for a patent, which Prius felt was very strong, although he knew the youngster had been anticipated by Lodge and Tesla. The patent was not original, and it did not put forth any new principles. Nevertheless, Marconi was definitely succeeding in the real world, while Tesla advanced in his laboratory in refinements of apparatus and in the theoretical realm. The differences in sophistication of knowledge on the subject are aptly described by one of Marconi's associates, Mr. Vivian. We knew nothing then about the effect of the length of a wave transmitted governing the distance over which communication could be effected, the colleague stated. We did not even have the means or instruments for measuring wavelength. In fact, we did not know accurately what wavelength we were using. Prius's initial work in his study of earth currents and induction effects generating from normal telegraphic lines in the 1880s and 1890 seconds led him to realize the strength of Tesla's system. Marconi, at that stage, had an understanding of the role of the Earth in conveying electrical energy. He was utilizing the principle of radiation through the air according to Hertz's apparatus, without understanding why. He did make use of an aerial and ground connection, but this setup had already been published widely in 1893 by Tesla. Other principles were taken from Oliver Lodge, who was in apparent dispute with Guglielmo Marconi. William Prius was well aware that they had been anticipated, but he could also see Marconi advance markedly, while his precursors basically stood still. After Marconi rejected Prius's suggestion that they request the use of Tesla's apparatus, the British nobleman was placed in a conflictual situation. In August 1897, he mailed a Avatar's dispatch. I regret to say that it must stop all experiments and all action until in the conditions that are to determine the relations between your company and the British government departments who have encouraged and helped you so much. But the die was cast, and Prius became helpless to stop what he knew was a complex form of piracy. He became ill and retreated to Egypt, where he stayed ill. Marconi was also being aided by H. Militus Hosier, director of Lloyd's, who, according to one account, succeeded in sending reasonably clear messages through Hosier's apparatus in one place, at least where Marconi himself had failed. Lloyd's also contacted Tesla to rig up a wireless set, shipshore in 1896 to report the international yacht race, but Tesla refused the offer, claiming that any public demonstration of his system on less than a worldwide basis would be confused with the amateurish effort being made by other experimenters. Instead, Tesla performed a long-distance clandestine experiment which he told no one about, not even his workers. Sometime in 1896 or early 1897, the inventor turned on his generator to produce continuous trains of oscillations and took a cab to the Hudson River. There he caught a boat and ferried up to West Point with a battery-operated machine suitable for transportation. He did this 2 or 3 times, he told the courts in 1915, but there were no signals actually given. I simply got the note, but that was for me just the same. In other words, having brought a receiving instrument with him, the inventor simply tuned it to the point where it began to respond to the oscillations emanating from his laboratory back at East Houston Street. That is, I think, a distance of about 30 miles. Tesla also considered harnessing wind power, the tides, solar and geothermal energy, and also energy released during the process of electrolysis. If water was separated into oxygen and hydrogen, these explosive substances could theoretically be used to generate the heat to create steam. Working along varying lines of research, Tesla also patented ozone production machines and devised a scheme whereby nitrogen from the air would be electrically separated out and blended with conveyor belts of soil to create a fertilizer machine. All the agriculturist needs, Tesla suggested, is to shovel a quantity of loose earth, treated by a secret chemical preparation in liquid form into the cylinder. An electric current is passed through the confined atmosphere. The oxygen and hydrogen are expelled, and the nitrogen which remains is thus absorbed into the loose earth. There is thus produced a strong fertilizer for a nominal price right at the farmer's home. On April 6, 1897, Tesla spoke again to the public at the New York Academy of Sciences. Over 4,000 people attended. With large photographs of dozens of radio tubes Tesla had designed gracing the walls, Tesla set out to explain his advances in Roentgen rays. Certainly, the audience was interested in seeing a remarkable device that revealed the human skeleton of a living person, but unquestionably most of them came to behold the Sorcerer hurl his thunderbolts. Tesla's world telegraphy system had finally come into clear focus. His plan was to disturb the electrical capacity of the Earth with gigantic Tesla oscillators and thereby use these Earth currents themselves as carrier waves for his transmitter. In 1897, he explained precisely how his world telegraphy system would operate. Suppose the whole Earth to be like a hollow rubber ball filled with water, and at one place a have or tube attached with a plunger. If I press upon the plunger, the water in the tube will be driven into the rubber ball, and as the water is practically incompressible, every part of the surface of the ball will be expanded. If I withdraw the plunger, the water follows it, and every part of the ball will contract. Now, if I pierce the surface of the ball several times and set tubes and plungers at each place, the plungers in these will vibrate up and down in answer to every movement which I may produce in the plunger of the first tube. There is a peculiar addition to this paragraph. If I are to produce an explosion in the center of the body of water in the ball, this would set up a series of vibrations in the whole body. If I could then set the plunger in one of the tubes to vibrating in consonance with the vibrations of the water, in a little while and with the use of every little energy, I could burst the whole thing asunder. The water corresponds to terrestrial currents, which are today known as telluric currents, and the plungers refer to his transmitters and receivers. The inventor thinks it possible that his machine, when perfected, may be set up, one in each great center of civilization, to flash the news of the day's or hour's history immediately to all other cities of the world, and stepping for a sentence out of the realms of the workaday world. He offers a prophecy that any communication we may have with other stars will certainly be by such a method. This article, which appeared in Scribner's, also discussed mechanized shuttles for wireless transmission of 8 miles in Europe. We see in these passages stemming from 1896 and 1897 that Tesla had already conceived of a total plan for his world telegraphy system, and that it utilized a variety of wireless modes, one being through the upper air strata, another by means of mechanical resonance, which he called teledynamics, and a third, and his most important, by riding terrestrial currents. His next plan was to measure precisely the frequency of the planet, and construct transmitters in harmonic relations to it. Nodal points could then be mapped out from, say, a wireless transmitter placed at Niagara Falls to precise positions for receiving towers on different continents. For all intents and purposes, no one, except for Marconi, had demonstrated that wireless messages could be transmitted more than a few hundred feet, and success only involved the modest goal of sending Morse-coded messages. Marconi's next plan, which would capture the world's attention, was to radiate the impulses across the English Channel. Certainly, Tesla had demonstrated all of the principles found in the modern radio years earlier, but his public demonstrations were held within lecture halls. He had established that he could illuminate lamps from a transmitter placed on the roof of his laboratory on Houston Street to his Hotel 26 blocks away, but these experiments were held in secret and were never publicized. The 1895 fire also thwarted his efforts to display long-distance effects, and when Lloyds of London contacted him, to the dismay of his secretary, George Scherf, Tesla rejected the offer to demonstrate his system's capabilities. Tesla, however, was not content with merely setting up a world broadcasting system that, from a conceptual perspective, is superior to our prevailing technology in that it would transmit power as well as information. He also suggested that he could contact the stars, create rain in the deserts, or cause wide-scale havoc. Tesla became the quintessential mad scientist. Through his inventions, the world could be dominated according to whim. The contradictions within the inventor began to pull him in opposite directions. In letters to the Johnsons, he calls himself Tesla, great inventor, and implies that, like Paderewski and other luminaries, he was not a mere mortal. But during his Niagara Falls speech, he denigrated himself. Tesla was somewhat wealthy during this period, but the requirements of his operations were beyond his means. And yet, Tesla shunned billing engineers when they sought his aid and voided a royalty contract with Westinghouse, though it was now worth a fortune. In June 1897, it was reported that Westinghouse had paid $216,000 for his patents. 24 as Tesla and his partners, Brown and Peck, were receiving yearly checks of $15,000. With an initial down payment of probably $70,000, this works out to about $250,000 for Atom. Year period. In a letter to Astor, Tesla places the figure at $500,000, but in either case, it was still millions of dollars less than its actual value. By this time, Westinghouse and GE had formalized their Entente Cordiale. This meant that a second gigantic corporation with numerous subseries would be benefiting from Tesla's invention, but the inventor would not receive a dime for it. The electric subway trains would also be implementing the Tesla motors and system, and again the inventor would get no compensation. Tesla's new plans would require enormous expenditures. Westinghouse was making it clear that his company would not be a source of funds beyond their former signed agreement, although it is possible that Tesla did receive additional revenues for other inventions, such as for his oscillators. At the end of the year, the inventor wrote his friend Ernest Heinrich, an engineer at the Westinghouse Corporation who also was a novelist. "My dear Heinrich," Tesla wrote, "it is true that I have not been quite well of late, but can assure you that I am physically and mentally all right at present. I have, however, still a little ailment which may be best designated as financial anemia, from which you are yourself suffering. If I am not mistaken. I wish you would remember me to all the boys at about Xmas time, for it is just possible that some of them might feel disposed to send me a token." There were other pressures as well. Tesla was having difficulties with his financial backer Edward Dean Adams, who was opposing his efforts to promote his wireless enterprise. There was this continuing competition with Marconi, and there were the painful echoes of his Serbian past, from Kosovo and his last youth. His parents and brother were dead, and he was away from his family not just in distance, but also in spirit. In yet another of so many letters sent, sisters Marika and Angelina pleaded for response. Tesla had sent funds on many occasions and a copy of his Martin text, but they wanted more. "Remember what your name is and where you come from," Marika wrote, ending her letter with the customary, "I'm kissing you in spirit." Part of him ached from the pain, and just as he was coasting high and ahead of the pack on the crest of the wave. Maybe it was the influence of the Boer War or the unrest brewing in Cuba, but Tesla's destructive streak began to emerge. His previous inventions were already reshaping human events. His newest creation couldn't link every remote hamlet or tear the world apart. He decided to experiment. With George Scherf present, Tesla placed one of his mechanical oscillator on the center support beam in the basement of the Houston Street building where his laboratory was located and adjusted the frequency to the point where the beam began to hum. While he was attending to something else for a few moments, it attained such a crescendo of rhythm that it started to shake the building. Then it began shaking the earth near about and other buildings with support beams in resonant frequencies. The fire department responded to an alarm frantically turned in. Tons of machinery flew across the basement, and the only thing which saved the building from utter collapse was the quick action of Dr. Tesla in seizing a hammer and destroying his machine. The device could be Frankenstein's monster, Tesla confided many years later. If not watched, no substance can withstand the steadily applied rhythm when its resonance point is reached. Skyscrapers could easily be destroyed with the steady building up of resonance from the time strokes of a 5-pound hammer. In another rendition of the story, told at another time, Tesla claimed that he had taken his alarm clock-sized oscillator to a building site in the Wall Street district. Finding one under construction, about 10 stories high of steel framework, he clamped the vibrator to one of the beams and fussed with the adjustment until he got it. "In a few minutes, I could feel the beam trembling," Tesla told a reporter. Gradually, the trembling increased in intensity and extended throughout the whole great mass of steel. Finally, the structure began to creak and weave, and the steelworkers came to the ground panic-stricken, believing there had been an earthquake. Rumors spread that the building was about to fall, and the police reserves were called out. Before anything serious happened, I took off the vibrator, put it in my pocket and went away. But if I had kept on 10 minutes more, I could have laid that building flat in the street. And with the same vibrator, I could drop the Brooklyn Bridge into the East River in less than an hour. Tesla told the reporter that he could split the earth in the same way, putting an end to mankind. The vibrations of the Earth, he said, have a periodicity of approximately 1 hour and 49 minutes. That is to say, if I strike the Earth this instant, a wave of contraction goes through it that will come back in 1 hour and 49 minutes in the form of expansion. As a matter of fact, the Earth, like everything else, is in a constant state of vibration. It is constantly contracting and expanding. Now suppose that at the precise moment when it begins to contract, I explode an atom of dynamite. That accelerates the contraction, and in 1 hour and 49 minutes, there comes an equally accelerated wave of expansion. When the wave of expansion ebbs, suppose I explode another ton, and suppose this performance be repeated time after time. Is there any doubt as to what would happen? There is no doubt in my mind. The Earth would be split in two. For the first time in man's history, he has the knowledge with which he may interfere with cosmic processes. Tesla calculated that this procedure might take more than a year to succeed, but in a few weeks, Tesla said, I could set the Earth's crust into such a state of vibration that it would rise and fall hundreds of feet, throwing rivers out of their beds, wrecking buildings, and practically destroying civilization. The principle cannot fail. End of Nikola Tesla. The Sorcerer's Apprentice. Thank you for watching.